Um, hey, Mr. J. It's Adrian Martinez from Period 6 Honors Physics, and I'm making a screencast about the air rocket activity. So, it says here that an air rocket is shot straight up into the air with no engine. The rocket is in free fall, and it falls back to the ground where it was launched. The rocket is launched with a low, medium, high, and super cap. The measure, and then it says to measure the time for the rocket to go up, etc. And that's what we did like a week ago, I think, for the thing whenever we went out. And yeah, so question number one was to sketch the diagram and basically show the motion. So here's the rocket, that little thing right there, and it basically goes up, slows down, and then comes back down and crashes. So the data for it, which was like they all had the same motion. The low one was about 3.42 seconds. The medium was about 3.96 seconds. The high one was about 5.48 seconds, and the super one was about 5.59 seconds. And that's to go up and come back down for each of them. So then number 2 says to sketch a velocity time graph and an acceleration graph. So the velocity time, it basically starts off faster and then steadily decelerates or slows down until it hits a velocity of 0. That's where it's at the maximum point, and then it comes back and keeps accelerating like in the negative. It speeds up but in the negative direction, and that's when it's coming back down along this little course right here, and then it crashes down there. And then the acceleration graph, that's basically, the acceleration is just gravity acting upon the rocket. So gravity is about 9.8, so in this case I just rounded up to 10 meters per second down. So yeah, that's what that is. And then number 3, it says to find the change in velocity. So it's simple, we just take the time multiplied by the acceleration. And so for the low one, we had 3.42 seconds total, and if it's accelerating at a rate of negative 10 meters per second every second, it should be about negative 34.2 meters per second. Well, it should be 34.2 meters per second slower than it was at first. Like, in a way, like when it's coming up here, it's positive, and it hits 0, and it goes negative. And then the same applies for the rest of these with their numbers, so it just multiplies out as a negative 10 for each of these. So we got 39.6 seconds for the medium, 54.8 seconds for the meters per second for the high, and 55.9 meters per second for the super. So we come further down, and we need to find, let me see, how fast it was traveling when it was launched. So that's just half of the entire function. So when it was launched for the low, it's basically just half of that. So it divides up to 17.1 meters per second at launch. The medium is 19.8 meters per second at launch. The high is 27.4 meters per second at launch, and the super is 27.9 meters per second at launch. And then this was just some other stuff that I wrote that was wrong, so that's why it's crossed out on the paper. And then it says, what is this? I think there's a 5 right there, but it got cut off on the picture. Yeah, okay. So it's asking if, let me see, if the speed right here is different from the speed right here, and it isn't, because it's the same acceleration, and like it travels the same distance, so it should change so the change in velocity should be the same, since it's like they just mirror images of each other, except right here the velocity is positive and right here the velocity is negative, but the absolute value of their absolute values are the same. So yeah, it's sort of represented here, but it's just the same thing that's up here. And yeah, here's the same thing. Original velocity is just the positive version of the final velocity, which is the negative version of the original velocity. Okay. 6. What was the maximum height of the rocket? So, I'm not sure about this one, but I basically got, if the velocity is the meters that it covers every second, if in the first second it covers 17.1 meters per second, 17.1 meters, and then gravity is causing the rocket to slow down at 10 meters per second each second, then by the next second it should be 10 meters per second slower. So in 1 second it covers 17.1 meters. In the next second it's going to cover 10 meters less. So we subtract 10 and we get 7.1, and that's for about 0.71 seconds. So that's the only height that it gets to cover there, and that adds up with the 2 seconds to the maximum height to get to that high point. It's about 24.2 meters, and then the same applies for the rest. It's basically original, and then original plus that's off right there, I think. Wait, no, yeah, that's right. So the original distance covered plus that, yeah, it makes sense. I think you could see from my wording. I just can't quite like from what I have written. I'm pretty sure it makes sense. I just can't really say it right now for some reason. But yeah, on to the next page, we have question number 7. Let me see. It's asking if the acceleration was different when the velocity reached 0, and it wasn't, because if we come back to this graph over here, the acceleration is constant throughout the whole time, but also we see that, we know that acceleration is basically just the slope of the velocity time graph, and the slope remains the same, and even though it's at 0 velocity, the slope is still like a negative 10 meters per second. So yeah, the slope is not changing ever, so acceleration is always the same. And then number 8, what was the total distance that the rocket traveled? So that's just like everything that it traveled regardless of like anything. It's just, so if it starts here and then it comes up here and it goes back down to the floor around where it started, it's just the addition of all that. So the low one traveled about 48.4 meters, the medium traveled 59.2 meters, the high one traveled 104.4 meters, and the super traveled 107.4 meters. And then number 9 asks, what's the displacement? And the displacement for all of these is 0, because as we remember from the prompt, it says that it starts off like at the 0 point at the origin, it gets launched and then comes back down to the origin. So like since it ends up at the starting point, there's no distance from the starting point, so therefore displacement is 0. Yeah. And then 10, it asks if 8 and 9 are different answers, and yes they are, because one's asking for displacement, the other one's asking for total distance, and they're like different, because one is just all the distances added up, like, well, I guess the absolute value of all the distances added up, so negatives don't really come into play, so you don't subtract anything, you just add everything. And then displacement is just like we said, it starts here, comes up, and then comes back here, so it's 0. Or if it starts here, comes back up, and then ends up on this little line right above the previous line, then the displacement would be 1 line up. Or yeah, they're just 2 different concepts, so they have to be different in this case, because they just are different in this case, but there are cases when it's the same. So yeah, that's it. That was the air rocket activity, and I'm done. Bye.